Okay, today we are looking at the first section of chapter 9, which deals with quadratic graphs and their properties. So hopefully by the end of this lesson, you can say that I can graph a quadratic function in the form of y equals ax squared and in the form of y equals ax squared plus c. So the point of this video, we're just going to go through basically some terminology with you, and then we're going to have an in-class investigation. But the first thing we got to talk about is quadratic functions. Can be written in the form y equals ax squared plus bx plus c, and we talked about that last chapter already, and that is simply known as standard form. So we are going to continue talking about standard form, and the big thing is this part, and we're going to be talking about these coefficients, specifically the a, the b, and the c, so we got to be aware of what term they go with. So the a is always with the x squared, the b is always with the x, and the c is just the constant in the function. Okay, so what are we going to be looking at today? Well, we're going to be looking at some graphs. So you're going to be doing them on some graphing calculators or with your Desmos program on your smartphone, but we're going to take a look at how you do it by hand first quickly. So if we were just going to make a t-chart of the parent function, y equals x squared, again, this is our parent function. That's the one we're going to be comparing everything to. So basic way we'd be doing it is we'd be making a t-chart. I shouldn't have put a 0 there because we want to have 5 numbers, and typically it's a -1, -2, 0, 1, 2. And how do we do that again? You'd plug in a -2 and you'd square it, so you get a 4. You put in a -1 and you square it, and you'd get a 1. A 0 squared is 0, 1 squared is a 1, and a 2 squared is a 4. So if I were to graph those points, -2, 4, a -1, 1, 0, 0, 1, 1, and 2, 4. So we should recognize some things about this function. First of all, the shape of it, it's not a best drawing of it, but the shape of it is symmetric. Symmetrical, it's on, if you look at the y-axis, it's symmetrical on both sides. It's like a mirror, that y-axis. Some other things you should know about it. It's called a parabola. So there's a new term for you, parabola. That's the shape of a quadratic. Okay, so we're going to talk about this thing called the axis of symmetry. That would be the line that cuts it in half. So it's like the mirror line. And in this case, it would be x equals 0. Okay, the vertex is the higher the low point, or you can also look at it as the point where it changes direction. So I'd say the vertex of this one is 0, 0. And is that a minimum or a maximum? Well, since it is opening up, we would say that that is a minimum point. The domain, again, what are the possible x values? And for this, the x could be all real numbers. There's no number that you could not put in for an x value and get an answer out. Okay, for the y values, however, if you look at it on the graph, one way to look at it is we got these things right here and then anything above that for y values. So how do we write that? For the y or the range, we would say y has to be greater than or equal to a 0. You can never get something less than 0 out of this. Another way to think about it, if you square something, you'll never get a negative number. Okay? So if we looked at this one, what would be the axis of symmetry here? Well, sometimes it's easy if you draw it. So we got this right here would be your axis of symmetry. So what would that be? It'd be the form x equals a -3. The vertex is this point right here where it changes direction, or that high point in this case. So that would be a -3, 2. And in this case, since it's opening down, we would say that that is a maximum point. The domain, x could be all reals again. There's no number that you can put in here. So all reals. And the range, since we got things from here and below for the y values, I can never get above that 2. We would say that the y has to be less than or equal to a 2 this time. Okay, one more and then I'll let you try. So this time the axis of symmetry, if we draw it out here, Axis symmetry should be an x equals a 3. If I look at the vertex, here's my vertex, so that point is a 3, 1. It's opening upward, so that vertex is a minimum. The domain, in this case, the domain, once again, is all reals. And the range would be y is greater than or equal to a 1 this time. Okay, and then you try one, pause it, try it, and then come back and see what you did. Okay, so if you drew it, if you're thinking of it, your axis symmetry would be right there, so that would be x equals a negative 3. If you thought about the vertex would be right here, which would be a negative 3, negative 1. And in this case, it's a maximum point since it's opening down. The domain, once again, would be all reals. And the range, in this case, would be y is less than or equal to a negative 1. Okay, so if you have any questions, make sure you come with them tomorrow, because tomorrow you're also going to be doing an activity in class. Okay, thank you, and that is a wrap.